Well, good afternoon, ladies and gentlemen. Thank you for coming. And we're looking for the lost symbol, but it was on his slice of pizza and he ate it. It's gone. So I tried to get Dan Brown to come, but he couldn't make it. Albrecht Dürer is kind of dead from 1500s, so he couldn't make it. Time machine's a little broken. Benjamin Franklin couldn't make it either. So you're stuck with me. So here I am. And what I like to do with you is just to show you a few places where this gentleman, Dan Brown, got his ideas for this novel and how he kind of put it all together. And hopefully it will stimulate you and you will do some research on your own. Okay? There's a few games in here that are fun to play. So first, let me introduce you to Albrecht Dürer. Okay. Albrecht Dürer was a gentleman, I assume he was, let's see, who lived in Germany in the early 1500s. And he was a very exciting person. Okay. His father, also named Albrecht Dürer, came from Hungary. Their original name was, I believe, Jilt, something like that, which means door in Hungarian. And when they moved to Germany, he translated it into Tor, which is door, and eventually it came Dürer, which means door. So it's Albert Dürer. Here you go. This guy was a genius. He was a philosopher, a mathematician, a sculptor, a painter. You name it, he did it. Name it, he did it. And one of the things that he did was he made this wood carving, Melancholia. That's right here. And you can read all about it if you want to go on the internet and read it. And what you see is it's a comment on art and technology. And you see there's an artist here, and it's got all the tools around, and she, I believe, is very melancholy because even though you have all these tools and stuff, creativity doesn't always come to you see. So there's a kind of sadness to this picture. But what's of interest to us and to Dan Brown was this little piece back here. This little piece back there is it's a magic square. Let's see if I can find it. This is a magic square. It's a 4x4 magic square. You see it has 4 rows and 4 columns. And let me explain to you what a magic square is. A magic square is an arrangement of numbers so that each row, each column, and each main diagonal has the same sum. When all the numbers are added, has the same sum. Okay? The value of the sum is always equal to m times m squared plus 1 over 2. So that, in his case, a 4x4 square, the sum is equal to 4 times 4 is 16 plus 1 over 2. So you see that in his case, the sum is equal to 17 times 2 is equal to 34. So if you add each row, 16, 3, 2, and 13, that's 34. This is 34, this is 34, this is 34. This is 34, this sum is 34, this sum is 34, this sum is 34, this sum is 34, and this sum is 34. Okay? That's a magic square, by definition. Okay? Now, going a little bit more into magic squares, there are three types. Obviously, a 4 by 4 is an even magic square. It's called even. Not only even, but it's called doubly even. And the reason it's called doubly even, it's because it's divisible by 2 and it's divisible by 4. See, 4 is divisible by 2 and by 4. There is also a singly even type of magic square. And a singly even is divisible by 2, but not by 4. For example, a 6 by 6 is a singly even magic square because 6 is divisible by 2 evenly, but it's not divisible by 4. Okay? So 4, 8, 12, 16, those are all doubly even. But 6, 10, 14, etc., are not divisible by 4. So those are singly even. Okay? And then there's the odd magic squares. The odd, like 3, 5, 7, 9, etc. Now these magic squares have been around for thousands of years. Okay? There are some very famous magic squares. This is one of them. Okay? There's another famous magic square. Okay? And that's it's called the Lo Shu magic square. Okay, let me show it to you. This is probably the most famous one, the Lo Shu magic square. Okay, here it is. The story goes that thousands of years ago, by the Lo Shu River, they had some sort of a problem, and they didn't know exactly how many things to sacrifice in order for something to happen. And then the answer came on the back of this turtle from the river. And you can see the back of the turtle has 1 dot, has 2 dots, has 3 dots, has 4 dots, 5 dots, etc. Okay? If you look at the way this thing is arranged, you see it's arranged this way. Okay? So that's a 3 by 3 magic square, or the divine turtle. This is probably the most famous one. And you see that each row, each column, and each main diagonal, since the order is 3, the sum is going to be 3 times 9 plus 1 over 2. Okay, this is 10. 10 over 2 is 5, and 5 times 3 is 15. So you can see that each horizontal, each vertical, and each main diagonal adds up to 15. Okay, I did some work on the odd magic squares, and the doubly even magic squares were figured out by Mr. Durer in the early 1500s. Okay. And the singly even, about 1918, there was a gentleman in England Okay, and his name was Tracky. And what he did was he figured out that you could do the singly even by using combination of odd ones. This is the hardest one to do, but you can generalize the particular way of doing it. But I did some generalization last year, and I added my name to this. So we have the Brumnak-Strachey method. Okay. Now, I wrote a paper on these magic squares, and I had a couple of people from here help me out. And what we did was we made a computer program. Okay, so I wrote the paper. Professor Metaxas over here, he wrote the code. And our technician, Steve Throwbridge, he did the layout. And now you can go on the internet and you can say things like here. You can go to our website and you can tell it the size square you want and calculate, and there's your square. You want to do a 25 by 25 magic square? Well, here it is. And each vertical, each horizontal, and each main diagonal adds up to 7,825. Okay. So you guys, if you want to play with this, you're welcome to play. Now let's do Durea square, a 4 by 4, and here it is. See, everything adds up to 34. Benjamin Franklin played with magic squares, and he did an 8 by 8. Here's an 8 by 8 magic square by Benjamin Franklin. Okay. This is not Benjamin Franklin, this is a real magic square. The problem with Benjamin Franklin's square, it's not magic. Why? Well, it does a lot of magical things, but his two main diagonals don't add up to 260. So by definition, it's not a magic square. Because a magic square is where each vertical sum, each horizontal sum, and each main diagonal adds up to the same number. And his does all sorts of other things, but it doesn't do that. So by definition, it's not a magic square. Okay? And the other concept that I'd like to introduce you to, besides these magic squares, that Dan Brown used in his latest novel, The Lost Symbol, is ciphering. Ciphering. How do you write code so that nobody understands what you're writing? There was a movie out called help me out, the something Whisperer, where during World War II, the Navajo, the Army and the Marines, the Code Talker? No? See, the old guys are remembering all this. It's a story where the military took Native American Indians and put one of them with each platoon, and they gave them a radio, and then these guys would talk to one another in Navajo, and the Japanese didn't understand what was going on. So they didn't need a code. They had a built-in code. You see. So that's one way of doing symbols. Now, this is very interesting topic because there's whole places in the government, the CIA, et cetera, that tries to break codes that people use, code breakers. Now, I don't know if anybody's familiar with this, but how do you think we got our symbols, our numerical symbols? If you have these many items, what do we write? 1. Well, the original ancient way of writing 1 was this. If you have these many items, what do you write? 2. If you have these many items, what do you write? The original way they wrote it was like this, 3. And if you observe what's going on, they're counting the number of interior angles. Look at this. Here's 1 interior angle. Here's 2 interior angles. Here's 1, 2, 3 interior angles. That's why how many things we got there? 7. The original way of writing a 7 was like this, and in parts of the world it still is. Why? Because there's 1, 2, 3, 4, 5. Where's the other 2? I don't know, there's 7 of them. I can't see it. As my students know, the excuse for that is that I'm too close to the board and I can't see it. Okay? Yes. 5, 6, 7. Okay? And guess what? No interior angle, 0. Okay? So whether that's true or not, I don't know, but that's one way of explaining our symbols to denote a certain number of items. Okay? Right now, in the 1300s and the 1400s, there was a society called the Masons. That wanted to communicate among themselves without other people understanding what they wrote. So what they did was this. You see, they made an X, and they made, well, let me put it the other way. They made an X, and they made a structure that looks like this. Now, looking from above, this may look like some sort of a farm, and usually pig pens look like this. So that's why this is also called the pig pen cipher. And the idea of a cipher is to use a symbol to denote a concept. So what they did here is they wrote the alphabet like this: A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Okay? I'm showing off. And if you want to refer to the first letter in that position, you just write it. For example, you see this would be an A. This would be an I, you see. But if you want to refer to the second number in the letter, in that position, you draw the symbol. For example, if you want X, it's in here, but it's the second letter, so you put a dot in there. Okay, so this is X. All right? So let's write something. I don't know, let's write something simple. Let's write pig. So pig would be the second letter in here. The first letter here. And the first letter here. So that's pig. And you can write anything you want like that. So that's cool, but what's the problem now? Well, everybody knows this. So what's the big deal? What's the secret? If you know I'm writing like this, all you got to do is do that and you know what I said. So how do I make it hard for you to figure it out? Yeah, you can simply put in a key. For example, don't start with A. We're going to communicate, however, I'm going to start like this. I'm going to start with another word in here, key. And then A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q. But what's the problem? Well, I used it already. So you see, so you can't. So I used the K, the E, and the Y. So A, B, C, D, E, F. E is no good. So you can't use these again. You can only use them once. So we have to remember the K, the E, and the Y. So it's A, B, C, D, no E, F, G, H, I, J, no K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. So if I want to write pig now, I would have to write it this way. I would have to write P, okay, I, and G. So it's pig. This is P-I-G. So now you see it's harder because if you know I'm writing this way with a key in front, and you can put whatever word you want in there, as long as the receiver knows that word, they can figure out what the code is, what is being said. Okay? So that's nice. Okay, but Dan Brown wasn't happy with this. Says, yeah, that's cool, that's good, but it wasn't happy. What he did is he took Durer's magic square, he took Durer's magic square, the one from his Melancholia. Okay, let's see, let's try to go back here and find it. So his magic square looks like this. 1, And then here, 14, 15, 4. And then he has 9, 6, 7, 12. And then he has, I believe that's a 5. 5, 10, 11, 8. And the top line is 16, 3, 2, 13. Okay, now let me show you at this point, let me show you how to make this 4x4 magic square according to Durer's directions. Okay? And Durer said that for a 4x4 magic square, all you have to do, and this is guaranteed that it comes out every time, you have to start either here or here, and think of the two main diagonals, and you start counting, but you only write down the number if it falls on the main diagonal. If it doesn't fall on the main diagonal, then you keep the count, but you don't write down the number. For example, you would write, and you can start either here or here. So let's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So you only write down the number if it falls on the main diagonal. Then you go backwards, and you fill in the rest. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Guaranteed everything adds up to 34. Okay? But this carving he did in 1514. And if you look at the magic square that he has in the carving, you see that cleverly he arranged it so that the date of the carving is the middle two numbers in the last row, okay? Which is very clever. This guy was pretty sharp. Okay? Now let's see how he did this. Well, there are other ways of doing Durer's magic square, and the way he did this was the following. Okay? He started over here, and he went this way, this way, this way, and this way, going up. So here's the main diagonals. So he wrote 1, 2, 3, 4, and then he went that way. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay? And then coming back, he went this way, the same way. This way, and this way. So coming back, he went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This also is a magic square because each row, each column, and each main diagonal adds up to 34. Okay? But very cleverly, he made the middle two numbers of the bottom row come out with the date that he did this carving. This is the extra complication that Dan Brown put in his novel. Okay? So instead of putting in a key, he left this the way it was. However, he arranged the letters in here, this way. So he arranged the letters in here, so that you would put the first letter here, the second here, the third here, the fourth here, fifth, sixth, seven, eight. So you had to know where the letters are. So you see they're scrambled, definitely scrambled. Okay? So that's another extra complication. And not only that, but he added a third layer of complication. The message, after you unscramble all this stuff, and if you read the book, you'll see it, the message didn't mean anything. Why? It wasn't Latin. So after you figured out that they used the Masonic cipher or the Pigpen cipher, and it was arranged in this format of Durer's 4x4 magic square, and you figured out what the letters were in the proper order, you now had to know Latin to figure it out. So that's the story here. Okay? So you have here a nice novel that's it's, if you like chase scenes, this is good. And he's got all sorts of symbols and stuff like that. And he definitely, he claims this is the lost symbol. I don't know, that's a zero. No interior angles. Okay? So it's a very interesting novel, and this is where he got all these ideas from. You see, the magic squares, the ciphering, plus the extra complication that after you've figured out what the letters were, unless you knew Latin, it had no meaning to you. Okay, so that's basically it. Now, he has in another part of the book, he also uses Benjamin Franklin's square. So this is Durer's square. So he used Durer's magic square. He used the Masonic cipher. Okay, and then the message was then written in Latin. Okay, so you had to know Latin. And then there was another complication to the whole thing where he used an 8x8 square by Benjamin Franklin. Okay, and let me go find this square for you here. And of course, we know that it's not a magic square because, you see, here is the square, but the two main diagonals do not add up to the magic sum. Now, just to see if that works, an 8x8 should add up to 8 times 8 squared plus 1 divided by 2. This should be the sum. That's a 2. 64 plus 1 is 65. And that's a 4. And 65 times 4 is 260. So the sum here of each row, each column, is 260, but the two main diagonals are not 260. So by definition, it's not a magic square. But look what else this thing does. It's amazing. If you add these, or these position, those are 260. This and the two corners are 260. This and this is this. You see these arrows. These two corners are 260. These four corners are 260. The four corners and the four middle ones are 260. Yes.
Did Franklin know that?
Yeah. He knew this. Yeah. So Then he made a 16 by 16 magic square. Okay. That I did not check if it's true or not, but the 8 by 8 isn't. But Mr. Brown stops here. He says 8 by 8 is okay. And although it's not a true magic square, he uses it. So now he calls these bent rows and stuff like that. Now, the reason I'm showing you these on the internet is I hope people will go look, okay, and go look at all these ideas of magic squares and Masonic cipher. As a matter of fact, there are websites where you can get the Masonic cipher as a font, and you can install it on your computer, and that's how I wrote this little note for you. Okay. And then you can type in Masonic cipher or Pigpen cipher. Now, what did I write here? Well, let's see. What did I write? Should I tell you, or? I don't know. Let me see. I don't remember. That's why every time you use a key, you should write it down. This is like having many passwords. And the only person that you're excluding from there is probably you, because you forgot what password you used. Okay? So let's see, what did I write here? I wrote this. Now, one way that code breakers use to break codes is that they try to figure out what language it was written for. And then they look at the language and they figure out which letter occurs most often in that language. For example, in English, it may be the letter E. Then they look at the message and they check which symbol occurs more often. That's probably the E. And then they go from there. Okay? So they try to break the code. But what is this? Okay. Well, notice the first hint here is that it's laid out in a 4x4 arrangement. And that's one hint, because probably we introduce this level of difficulty, or this one, okay? But it's probably something to do with a 4x4 square, okay? So probably I'm going to have to read it this way. This is going to be number 1, okay? This is number 2, this is number 3. Okay, this is number 4. I'm sorry, number 4 is down here. Okay, if I'm using this one. And then number 5 is here. Okay, number 6 is over here. And number 7 is here. And number 8 is this position. And 9 is here. 10, 11, and 12. and then 13, and 14, and 15, and 16. So that's the arrangement of the symbols. Okay? Now, that's number one, and according to this, this would be an E. Okay? And if I did that, and I figured out I'm going to get gibberish. And that's where the extra complication comes in, and he mentioned it. Maybe there's a key to this. And if you don't know the key, you don't know where to start. Well, since you're all my pals here, the key is the word key, just like I did over here. That's my key, the word key. So this, which is the number one, is really a B. Okay? So that's a B. All right? And here's the number two. Okay, and number two, see, I'm over here now. That's an E. It's the second letter in that position. And here's the number three. And that is the first letter in this position. That's a Y. And where's number four? Here it is. That's number four. And number four is the second letter here, you see, because it's got a dot. And the number five is this, which you see is N. And then the number six is this symbol, which is D. Oh, look at that, beyond. And if you decipher everything else, it says beyond Dan Brown and the lost symbol. Mm-hmm. So that's the little presentation. I hope we didn't put you to sleep. I hope you enjoyed the pizza and read the book. And I hope we brought you a little bit of entertainment, a little bit of insight into symbols, ciphers, magic squares, and languages. Thank you very much. Thank you.